All right, so next. So who heard of Enstratus before? Good, a lot of you do. So they changed their name because someone else had that name, so it's now Enstratius, and they're acquired by Dell. So there might be a good story behind that that's more interesting than just someone else had the rights to it. But Greg's kind enough to join us here, and of all things, their geniuses are based in Minnesota. So what a wonderful, another success story from Minnesota. So thanks for joining us, Greg.
Thank you very much. And thank you for inviting me, and thank you for allowing me to join the conversation. My name is Greg Moselle. I'm a Solutions Architect Senior Manager with Enstratius, now part of Dell Software. My title just changed. I've been with Enstratius for nearly 4 years now, and as such, I've functioned in many different capacities, from sales engineer to salesperson to marketer to technical writer to DevOps implementer to deployer of cloud software to engineer and all of those things. And now primarily I function as a consultant and architect for the cloud management platform that is Enstratius. I don't remember what our new name is for the DCMC? Multi-Cloud Management Platform, let's say. Still working on that. So yes, we did get acquired early May, and now we're part of Dell Software. My apologies to the sales team that's here. I didn't make a very salesy presentation, but with a nod to them, I will say that what Enstratius does is implement an API of APIs for cloud integration. So we have a platform for harmonizing the various cloud API implementations called DaSign Cloud. If you're interested in learning more about that, I can talk to you afterwards. But it is an open source library for interfacing with cloud APIs. And today, I'd like to take you through some cloud adoption case studies. Over the past couple of years, I've had several occasions to be sort of at the forefront of cloud adoption with enterprise spaces. And so what I'm attempting to give you today, even though we're in the forward-looking part of the presentations, is a backward glance at what cloud adoption has looked like using a couple of metrics, and maybe there's some history that we'd like to repeat, learning lessons from that. So think of this as a dispatch from the cloud front. So today I'll take two approaches to the case studies that I have with me. I'll take a qualitative approach. We'll take a moderately deep dive into a case study with a software firm in an attempt to get an idea for what it means to adopt cloud technology from a process standpoint and really focus on the how of doing it successfully. In the quantitative section, I chose a metric of server launches because everyone's familiar with that metric, and I think it's the core of infrastructure as a services goal. And I also have a short summary of API metrics, and we'll look at some of the implications that had for architecting for a cloud solution. So two cases here. Case one and two are both software enterprises. The first one is a bit larger than the second. The first one, we're looking at thousands of VMs and hundreds of users, around 500 or so, and approximately 80 different cloud accounts brought into management by our governance platform. Case two is a smaller corporation, a bit less users, earlier in the adoption curve, but taking a different approach that I'll say more about in a few moments. Finally, we'll look briefly at an instance of a cloud API endpoint and take a look at a quantitative analysis of the types of API calls that are being made. Focusing on infrastructure as a service is primarily what we do for management, but we also do integrate with PaaS offerings. And I'm making the statement here that infrastructure as a service is about meeting the needs of users for their compute needs, and you could also lump storage into there if you wanted to. And in both of the cases for these corporations, the single biggest driver for the adoption of the cloud technology was on-demand self-provisioning. And this means the end user themselves are able to provision VMs and compute storage resources for themselves, not just the guy in the data center that's the VMware manager, but the end user themselves, being able to, through a interface, either a web UI or through an API, be able to provision their own compute and storage resources. And we're talking about provisioning times on the order of 40 seconds to 2 minutes for compute resources. So kind of put that into context with what you're used to for provisioning times in your own data center. It's also worth noting that both of these case studies are private cloud implementations, so not even nodding towards the public cloud in this case. So before we get into the charts of it, we'll look at a qualitative dive into the first case study here. And I think this is a good success story to use as a model for going forward for cloud adoption. This case was, again, the larger of the two software companies, again, hundreds of users and thousands of VMs, and they did it right. And I even use the terms managerial genius on here, two words you don't typically see used in the affirmative right there together. What they did early on was they formed a core operations team of about five people, about 5 FTEs, and the FTEs were not spread out amongst 15 people. This was a core dedicated group of operations engineers and a couple of junior engineers as well. And what they did to drive the adoption of the cloud infrastructure as a service offering is a couple of things. First, they drove the adoption early and they paid for it. And what I mean by paid for it is not that they suffered for it, is that they planned to pay their technical debt early by understanding the risks that were associated with the adoption plan that they had in front of them and what it would take to achieve their goals. And the way that they did this is shown kind of at the bottom with the generic people icons there. They piloted users early. They identified core target groups within the organization that would be highly interested candidates for adopting this mechanism for provisioning their own resources, development users, development teams, and so forth. And then they and in using that process, they built out an onboarding plan for bringing on users en masse. They made a huge investment, not just in cloud, but in the government's technology that we provide. So the power to the users of provisioning their own virtual machines and compute resources is one thing, but having the ability to maintain controls over that without getting in the way of that process is another question entirely. And that's kind of where we fit in. So the management team wanted to know how much were the VMs costing? How much does the user think the VM costs? $0, right? They're free. Just keep provisioning away and having all of this cloud resources kind of just hanging around. So we developed technologies to help. I heard a term earlier called Reaper. We developed something very similar. This is a very important problem to solve, right? We want to make sure that VMs, once provisioned, are actually doing something useful and not just hanging around consuming space. Initially, they went with a single cloud solution, and by single cloud, I'm talking about a single cloud technology here. They did this to limit the scope of their effort early on, and they did this to limit the risk. So they didn't try to bite off more than they could chew and try to solve all the cloud in one fell swoop. They are currently multi-cloud. As I mentioned, we have around 80 different cloud accounts in one particular instance of deployment, and more on the way. They understood also, this is kind of a big thing for me when I was in early discussions with this case, they pushed the envelope of cloud. They knew that they were going to drive the maturation of the cloud technology and the governance technologies. So they broke it, then they fixed it, then they demanded patches of the cloud technology, then they broke it again, and they kept doing this. And they understood that they were driving that maturation process, so they took that as a known quantity that they were going to incur throughout the adoption process, which is a hard sell if you're the internal team about trying to make that adoption work. Oh, and finally, once the operations team sort of had a process built out, they brought on the API and development teams for really starting to scale out the deployment of the cloud technology internally. So infrastructure as a service driven by their own API internals. So they come in the morning, this is West Coast, they start around 100 VMs for the day, and then they shut them down at the end of the day through their automation tools. Hopefully that looks okay. So what we're going to look at is a couple of graphs of the adoption of cloud as it looks through the metric of VM provisioning. So in this case, the blue part of the graph is individual days of provisioning for individual VMs. And the red line indicates the running average of launches per day. If the numbers are tough to read, we're looking at a peak of around 610 servers launched on a given day, again in this private cloud environment, and an average now reaching over 60 VMs provisioned per day. notice that in the early days of the deployment and adoption, kind of a low level of background noise of VMs launching. This is their onboarding process, the build out of their adoption policies. And next, we'll look at a couple of closer looks at the year-over-year comparison. So on the top, we've got the trailing year, so that's 2012 adoption. And notice that there's a fairly steady state of operations that ramps up slowly towards the end of the year, averaging out to be around 17 VMs launched per day. And here we're looking at in 2012 only about 15 cloud accounts and maybe 100 users total. In 2013, activity spikes up pretty dramatically. If you only take into account the year 2013, we're looking at around 150 servers launched per day. And again, peaking at around 600 per day. So I don't really have any idea for what this means for traditional IT provisioning of VMs, but I'm sure that you've all got some notion of how long it takes to provision a VM and how many you can provision each day. And remember, this is end users that are provisioning these VMs. Month over month, here we have a comparison of not just the launches, but the termination events as well. So the takeaway message from this slide should be a couple of things. One is that launch events are by far outweighing termination events, and this can be a signal, an indicator for the increased adoption of internal use of the cloud, and also that more systems are being moved to production where typically VMs are longer lived than in a development and test scenario. So as they move to production, you can see in late 2012, they onboarded a few large groups of users and moved several products into production on their cloud, and you can see the increase in launches. Case 2, we'll move rather quickly through this one. This is, again, the smaller of the two cases, and the patterns that you're seeing here are very similar to the ones we looked at for the early adoption of the other case that were looked at. So here, throughout the entirety of the project, about 9 months, we're only averaging about 4 servers per day. The human cost of adoption in this particular case is much less than, or the human investment, I should say, is much less than in the other case. In this case, they only have a couple of dedicated employees for the cloud adoption process, and as such, and very much less users at this point in time, so the number of servers launched is quite a bit less. Similar patterns on the year-over-year comparison for the number of servers launched, and averaging only at this point in time for throughout this year about 3 servers per day. You only have around 5 to 10 users on the system at any time right now. The month-over-month comparison brings it to light an important point, I think, about, especially if we think about the DevOps community and the DevOps philosophy. This client is really leveraging DevOps technologies like Chef and Puppet for the provisioning of their VMs. So notice that the launches and terminations are almost equally balanced, and that I think is due in some part to the approach that the DevOps community takes towards servers, treating them in a much more ephemeral way. The servers come online and then they do the thing that they're supposed to do for only the time that they're supposed to do it, and then they go away. DevOps being primarily concerned with the process that creates a VM and makes it do something useful rather than the long-lived VMs that everyone's scared that if it goes down, the whole app goes with it. So launches and terminations are quite evenly balanced. I'll try this side. Okay. Wow, that did not render well. I'll take the developer's way out. It looked fine on my laptop. It compiled there. I don't know why it's not running in production. My apologies. I'll try to get this cleaned up maybe for the publicly available one. But I think we can take a look at some of the numbers in any case. What this is meant to show is a summary of a single day's usage of a single cloud API endpoint and a comparison of the types of calls that are being made. The management platform that I took this data from is concerned with maintaining a up-to-date state of the cloud. And as such, the left-hand column is a listing of the types of calls you would expect to see there. A lot of list calls, a lot of gets to the cloud, tell me what the state of the servers are, tell me what the volumes are doing, and so forth. things that are very time sensitive. A server launch, the management platform is very concerned about tracking the life of that VM from the time of its inception to the time where it reaches a running state. So we see a lot of list calls here. In fact, 99.99% of the calls throughout this day were list calls. Creation events are very much less of the activity from the API standpoint. Create calls, if you can see on the right-hand side there, to create a VM, only 40 calls this particular day, which, depending on your perspective, might be a lot or not. So that accounts for the other 0.01%. And then delete events are only 7 made per day there. This comes out to 566,000 API calls against one cloud endpoint for approximately, at this point in time, 15 cloud accounts. And the question that came up immediately when I posted these numbers internally was, doesn't that seem like a lot? And my question was, compared to what? And that question was not received terribly favorably, but in truth, compared to what? Does it seem like a lot? How hard can your API be hit to service your users? And the case that I made to defend my statement was that you should think of your API, if you've got one available, as the entryway to your store or your business. And if it's not available for a justifiable use case, then you're essentially turning away business. And internally, the case that we're talking about here sent that message to the operations team, and we made some adjustments to the architecture to accommodate the use case. It actually was a lot for just one server because there was additional load testing going on in parallel here. So what we did was pretty obvious. We started with one cloud API endpoint and threw a load balancer in front of the cluster that we provisioned to handle the additional load. So this is just a small glimpse into the adoption of cloud computing. Again, just using one simple metric here. In our position as a multi-cloud management platform, we have a wealth of data that we're only just beginning to mine for this type of information. Carrying on to the previous talk there about analytics and real-time data, what we think we can do with this information going forward is start to make predictive recommendations to the end user. We know, for example, not shown in any of the slides here, how much time it takes in a given cloud for a VM to transition from starting to running. So we have hundreds of thousands of data points that we can start to use to trend and make recommendations for the performance of launches and other events like storage I/O. So infrastructure as a service, I'll make the case that it's about the end user, empowering them to be able to provision their own compute and storage resources, and that's what these two cases did, and did it fairly well. With a nod also to the governance component of that, empowering users and then maintaining some viewability into how the adoption is going. One takeaway from the success case there is build early and pay your technical debt up front. I know that's not terribly groundbreaking advice, but it's also a good advice, let's say. Engineering is expensive, and you'll end up paying that debt at some point or another, so it's better to pay it early and be ahead of the curve. And the final thing I'll mention for a recommendation is build a robust architecture over time. Don't start with a huge, highly available 45-node cluster if you don't need it, because you probably don't for your early POCs and onboarding trials. Build something small, find out where its breaking point is, adjust, and keep building. And then when you're ready to go to production, you'll know the limits of your systems and be able to architect for success there. So with that, thank you very much, and
thank you.
Around for questions if you have any.
Yeah, I would say if you don't pay your technical debt up front, then you're going to have a low FICO score too. So any questions quick before we move? Awesome. You have a great solution. Again, thank you very much for being here, Greg. Awesome. Videos. Thank you for being a part of the inaugural BigCloud event in Minneapolis, Minnesota. We'll see you next year in March. To all of you, thank you. To our sponsors, thank you very much. Have a great night, everyone.